The seventh learning objective in section 4.1 is to find the five-number summary and interpret quartiles for a data set. Before we look at this example, let's write down what the five values of the five-number summary are. They are the minimum, Q1, which is the first quartile, the median, Q3, which is the third quartile, and the maximum. In this example, the table below gives the salaries for some of the members of the 1996 World Series champion New York Yankees baseball team. Compute the five-number summary. These values are given in order from the highest salary down to the lowest salary for the individuals in the data set. When the values are ordered like this, it's easy to compute the five-number summary by hand. We can easily find the minimum. That's the value there for Wade Boggs. We can also easily find the maximum, which is the value for Cecil Fielder, 9,237,500. The median then is the middle value. If I count these data values, there are 11 of them, and the middle value is this one for John Wetland. There are 5 values higher than him and 5 values below him. So the median, the value that is splitting these data in half, is 4 million. Now, this lower numbered half, if we find the median of those 5 numbers, then we will have Q1. And of those 5 numbers, the middle value is Tino Martinez's salary, which is 2,300,000. And if we find the median of the upper numbered half, which is this value for Kenny Rogers, at 5 million, that is our Q3. Now, if you have an even number, then the way that you would compute this by hand is a little bit different, because the middle value would be in between two numbers. So for example, if we had 12 values here, then the median would be in between the 6th and the 7th values, because there'd be 6 values in each half. In that case, the smaller number is in the lower half and the bigger number is in the upper half. And then you would still could compute the median of the middle values, the mean of the middle values, to find the Q1 and Q3. Let's look at another example. The website Weather Underground tracks weather data from around the world. The following data is from Salt Lake City, Utah for April of 16 recent years. What is the five-number summary for the data set? Now these values, these days with precipitation, are not in order from smallest to biggest. So let's compute these using GeoGebra. I move the data up here so you can see that these numbers here match the values that are shown in the table above. I've entered them in, and I'm going to click on the histogram option to open up the one variable analysis. And when this window opens up, if you click on the summation of X button, it will give you the five-number summary. It's the last 5 values that are listed here in the output: 8, 10, 12.5, 13.5, and 21. So answer B is our five-number summary. Now let me explain how this would happen by hand. There were 16 values here. You can see that in the GeoGebra output as well. Our sample size is 16. So I'm not going to write the actual numbers down, but I'm just going to put 16 little X's here to show you how you could compute this by hand. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I need some more. 13, 14, 15, and 16. All right, so the minimum would be the first number. The maximum would be the last number. These are ordered now. We'd write them in order from smallest to biggest. And then the median would be in between the 8th and the 9th value. So it would be in between these two values here. Then I have 8 numbers in the bottom half, and Q1 would be in between the 4th and the 5th value, and Q3 would be in between the 4th and the 5th value of the upper half. So notice that since the median is in between two values, I'm including the value below it in the lower half and the value above it in the upper half. Okay, next, which of the following is a correct statement? 10 is the first quartile. Well, that is correct. That's our value for Q1, the second number in our 5-number summary. What does that mean? Quartiles give us separate the data into quarters, and the first quartile has a quarter of the data equal or below it. In other words, 25% of the values are equal or below 10. So let's look at these answers. 10 is the first quartile, meaning that 25% of the 16 years had 10 or fewer days of precipitation in April. That is a true statement. It's not that 25% had 10 or more days. It's not that 75% had 10 or fewer days. And it's not that 25% had exactly 10 days of precipitation.